All right, everyone, this is 11-19, another target costing exercise. You're going to want to print this up, but here's the problem to start with. Instant Image Incorporated, and remember, if you don't want to print it up, it's in the back of your textbook, or you can just open it up in Cengage and have that in one screen and us solving it in the other screen. So they tell us that Instant Image Incorporated manufactures color laser printers and sells for $460 and has a product cost of $230. So they break that down for us. And then it says it is estimated that the competitive selling price for color laser printers of this type will drop to $400 next year. Instant Image has established a target cost to maintain its historical markup percentage on product cost. Engineers have provided several following cost reduction ideas. So one of those ideas is to purchase a plastic printer cover with snap-on assembly rather than with screws to reduce the amount of direct labor by 15 minutes per hour. Or number 2, we can add an inspection step that will add 6 minutes per unit of direct labor but reduce the materials cost by $20 per unit. And the third is to decrease the cycle time of the injection molding machine from 4 minutes to 3 minutes per part. 40% of direct labor and 48% of factory overhead are related to running injection molding machines. So again, and also the direct labor rate is $30 per hour. So the first question wants us to determine, the first question they ask, hold on, let me find it here on the sheet. For A, they want us to determine the target cost for model J20, assuming that historical markup on product cost and selling price are maintained. So how do I want to put this up there? So I'm gonna put A, and A wants us to determine the target cost. Determine the target cost for model J20. And this is going to be under the new method. So the first thing we need to do is calculate out what our what our markup is. And so we can do this, we can look at our historical markup percentage. So we've got our historical, and I'm going to do markup percentage, and that's on product cost, and that's going to equal variable cost divided by, that's going to equal, how do I want to put this? We're going to do the selling price minus cost over our cost. So we know that the current selling price is $460, and the problem has told us that $230 is our cost over $230. So that's going to equal 100% markup on cost. Or we can also look at it, if we look at it this way, if we take the cost over selling price. So we know that that under the old is $230, and we're going to multiply that by 460, and so that's going to equal 50% of selling price or 100% of total cost. Okay, so that's the first step in that. So now we can come up with the new target cost that we want to look for. So to get the new target cost, it's going to equal the new selling price of $400. And I'm going to multiply it by the selling price, by the markup on the selling price of 50%. And that's going to tell us that the new target cost needs to be $200 per unit. Okay, so we currently have a cost of $230 per unit. We need to bring that down to 200. And so for B, where it asks determine the required cost reduction. So this is A. B, the required cost reduction equals $30, which is the old cost of 230 minus the projected cost, the new target cost of $30 per unit. So then C is where they have us actually evaluate the 3 engineering improvements to determine if the required cost reduction, also known as drift, can be achieved. Remember, it says do not round interim calculations, but round your final answers to 2 decimal places. So we're going to start off here. So I'm going to do this. I'm going to set this up the way the problem has it set up for you. So the first, remember in the first scenario, it says purchase a plastic printer cover with snap-on assembly rather than with screws. This will reduce the amount of direct labor by 15 minutes per unit. So if we're going to do the direct labor reduction, remembering that DL is the abbreviation for direct labor. So we know that we pay $30 per hour, the problem's told us, for direct labor. So if we divide that by the 60 minutes, that's going to come out to basically 50 cents per hour. But if we take 30 over 60, that gives us that 50 cents reduction. So we multiply that times 15 minutes. And that's going to equal a total direct labor reduction of $7.50 per unit. So remember, I've just taken the $30 an hour, divided it by 60 minutes, which means we're paying our employees 50 cents per minute. I'm going to multiply that by 15 minutes. That's going to give me the reduction of $7.50 per unit. The next one is to look at the additional inspection. Okay, so that's the second cost-saving measure that they gave us. And the problem told us for that, again, an inspection step will add 6 minutes per unit of direct labor, but reduce materials cost by $20 per unit. So if we're looking at the additional inspection, again, we're going to do the $30 divided by 60 minutes to get our minute rate. And they told us that that was going to increase by 6 minutes. So that's going to increase our costs here by $3 per unit. But we're also going to have the direct materials reduction. So here we've got direct materials reduction per unit of $20 per unit. So that's going to give us a cost savings there of $17. So that's going to go here for $17. And then the last one they have is the injection molding productivity improvement. This says decrease the cycle time of the injection molding machine from 4 minutes to 3 minutes per part. 40% of direct labor and 48% of the factory overhead are related to running the injection molding machines. So if we're looking to improve the cycle time from 4 minutes to 3, that's going to give us a 25% reduction. So if we improve to 3 minutes from 4 minutes, that's going to give us a 25% improvement in our cycle time. So we'll put 25% reduction. Okay, so when we're looking up here for 3, and remember, I'm sorry, this is 1, this guy is 2, and now we're looking at the third alternative. So we're looking for that injective molding productivity improvement. That's also going to have two parts. So we've got our direct labor improvement. And when we're doing our calculation here, we're going to take that 25% reduction that we calculated below. We're going to multiply that by the 40% where the problem tells us that the decrease in cycle time, and number 3, 40% of the direct labor and 48% of the factory overhead are related to the injection moldings. So we've got the direct labor improvement, 25% reduction times the 40% component that's of direct labor related to productivity, divided by the $40 of direct labor that they give us at the beginning of the problem. That gives us an improvement of $4, so we can reduce cost another $4. And then we've also got our factory overhead improvement. Again, we have that cost reduction of 25%, but factory overhead, 48% of that is related to the injection molding, and we're going to multiply that times the current $15 of factory overhead. That's going to give us $1.80, and that total improvement is going to be $5.80. So if we implement all three of the cost reductions, the direct labor reduction from buying the plastic part, the additional inspection, and the injection molding, we get a total savings per unit of $30.30. So we actually came in below the required cost reduction. So when you're looking at your problem, you've got your total savings for C. I want to make sure we don't have. And so we would implement all these. We can have the new selling price. We can sell competitively and still make our target markup. And that's how you calculate exercise 11-19.